In this video, we're going to start the KutaSoftware free worksheet under the Infinite Algebra 1 tab called Graphing Linear Inequalities. In this video, I'm going to do the first 4 problems, and then in 2 more videos, I'll do the middle 4 problems, and then the last 4 problems. So this worksheet is broken up into 3 separate videos. Our directions are to sketch the graph of each linear inequality. In number 1, we have y is greater than or equal to negative 3x plus 4. You can see that the format is very similar to the slope-intercept format, except we're not using an equation, we're using an inequality. But essentially the same applies. Our m, or our slope, is negative 3, and our y-intercept occurs at that point 0, 4. So we're going to find 0, 4. Then we're going to apply the slope to find the next point. Negative 3 is the same as negative 3 over a positive 1. So we're going to go down 3 and over 1 to the point 1, 1. Now this is where it becomes slightly different than a linear equation. First, we have to look at the inequality sign. Is it simply a greater than or less than, or is it a greater than or equal to, or less than or equal to? Since this is a greater than or equal to, the line is going to be solid. If it was a less than or greater than, so not including the equal to, then the line would be dashed. So since y can be these values, since it's greater than or equal to, it's a solid line. And now we have to figure out which way we need to shade. The easiest way to do this is to pick a test point. I usually pick the point 0, 0 since that's the easiest point to apply. So since I chose the point 0, 0, I'm going to put 0 in for y, and I'm going to put 0 in for x. Now I'm going to do the math and see if this inequality is true or if it's false. So I have 0 is greater than or equal to negative 3 times 0 is 0, plus 4 is 4. I know for a fact that 0 is not greater than or equal to 4. So therefore, the point 0, 0 is not within the shaded region. And the shaded region is where the true values lie. 0, 0 is not a part of that, so I'm going to shade everything to the right of the line that I drew. And of course, this is extended down. If I had a straight edge, it'd be easier for me, so I recommend using a straight edge. But you're going to shade everything to the right. And if you want to double check, go ahead and pick a point in your newly shaded region and see if the inequality holds true. Let's go on to number 2. Again, it's in the form of y equals mx plus b, except for the fact that it's an inequality. So we know our slope for this line is 3/5, and our y-intercept is at negative 5. So 0, negative 5 is one of the points, and then rise over run. We're going to go up 3 and over to the right 5. So 1, 2, 3 up, 5 over to the right. So that's at the point 5, negative 2. Now we're going to draw a line and connect. The line is going to be a solid line since this is a less than or equal to or a greater than or equal to problem. So since that equal to is included, it's going to be a solid line. Now we just have to decide which side of this line are we going to shade in. So which side holds the true values. Let's go ahead and use our test point, 0, 0. Plug 0 in for y, and we're going to plug 0 in for x. We'll get that 0 is less than or equal to negative 5, which we know is not true. 0 is greater than or equal to negative 5, so the point 0, 0 is not included in the shaded region. So that means, therefore, we're going to shade below this inequality line. And that's the answer for number 2. In number 3, we have y is greater than negative x minus 5. Negative x is the same as negative 1 times x. So our slope is equal to -1. And now let's plot some points. Our intercept occurs at -5, so 0, -5. And if the slope is -1, that's the same as -1 over 1, or we can do 1 over -1. Let's do 1 over -1. So our rise is a +1, and our run is a -1. So we're going to go up 1, and then over to the left 1. Now we're going to draw the line. However, this is a greater than problem, so the line is not going to be shaded in. That's because the values cannot be equal to that. Y is only greater than those options, so we're going to do a dashed line. Now we need to decide which way we're going to shade. Again, let's use that 0, 0 test point. And remember, if 0, 0 falls on the line, you're going to have to pick a different test point. But let's just use 0, 0. We're going to put 0 in for y and 0 in for x. So x is just 0, so that's 0 is greater than -5, which we know is true. So we're going to shade including that 0, 0. So we're shading everything above the inequality line. And that's the answer for number 3. Moving on to number 4, we have y is greater than -4. This is a relatively easy one to plot because the slope in this case is 0. So since it's greater than, we're going to do a dashed line and it's going to be along -4. So a horizontal line along the y equals -4 line. And now we just have to decide which way to shade. Well, we are saying that y is greater than that -4, so we know we're not going to shade below that line because that would be numbers that are less than -4. But we want to include numbers that are greater than -4, so we're shading above the y equals -4 line. And that's the answer to number 4. Join me in the next video where I'll go over numbers 5 through numbers 8. Before you do that though, please remember to click that subscribe button and subscribe to my channel, and also don't forget to like this video. In this video, we're continuing on with the Graphing Linear Inequalities worksheet provided by KutaSoftware. I'll leave a link in the description below as to how to access that worksheet. But let's go ahead and pick up where we left off, number 5. Y is greater than 2x minus 5. So our slope is 2, which is the same as 2 over 1. So 2 is our rise, 1 is our run. Our y-intercept occurs at -5. So we're going to find 0, -5 on the graph, and then we're going to go up 2 for the rise and over 1 for the run. Now we're going to connect those points, but not using a solid line. Since y is not greater than or equal to, it's only greater than. So the values along this line are not included in the inequality, so they don't hold true for the inequality. Now we're going to pick a test point. Let's just pick 0, 0 to see which way we shade. So we're going to plug 0 in for y and 0 in for x, which we know 2 times 0 is 0, so we're going to be left with -5. 0 is indeed greater than -5, so we're going to shade in including that test point. So this is everything to the left of that inequality line. Let's continue on to number 6. In number 6, our m, or our slope, is 7/4, and the y-intercept occurs at the +2. So when x is 0, y is 2. Now if we were to go up 7 and over 4, we would be off the graph, but we know that a negative over a negative results in a positive, so instead let's go down 7 and to the left 4. That will put us at the point -4, -5. Now we're going to draw a line and connect, and this is indeed a solid line, meaning that the values on the line are true for the inequality. Since y is greater than or equal to 7/4 times x plus 2. Now we're going to pick a test point. Let's use 0, 0 and see if that is true for this inequality. plugging 0 in for y, and plugging 0 in for x, that'll just become 0. And we have that 0 is greater than or equal to 2, which we know is not true. Therefore, we're not going to shade in including the 0, 0. We're going to shade in the other side, since our test point is not included in the shaded region. And that's the answer for number 6. And I apologize for my line not being completely crisp and straight, so I recommend using a straight edge at home, but I don't have the tools that I need here on my computer. But just remember, when you're doing this, just try and draw the line as straight as possible. Number 7, we have x is less than negative 5. Our slope in this case is undefined because it's a vertical line. Regardless of the y values, x is always less than negative 5. So we're going to locate the x equals negative 5 line, but it's going to be dashed since x is less than, not less than or equal to. So go ahead and draw that dashed line, and then we're going to shade in to the left since the x values are less than negative 5. So that would be negative 6, negative 7, and so on, regardless of y. And now on to number 8, the last problem I'm going to do in this video. Before we go over this, click that subscribe button, and also give me a thumbs up for this video. For number 8, our slope is 4/3, and our y-intercept occurs at negative 4. So 0, negative 4, and then we're going to go up 4, and to the right 3 for the rise over run. Those points are going to be connected with a straight line. Now let's see which way we're going to shade. Let's use our test point of 0, 0. If you plug in 0 for x, that'll be 0, so you'll be left with negative 4. Is 0 less than or equal to negative 4? No, that's not true. So we're not going to shade in including the 0, we're going to shade in the side that does not include 0. So that's everything to the right or below this solid line. And that's the answer to number 8. In this video, we're going to finish up the graphing linear inequalities worksheet, and I'll leave a link in the description below of how to get to that on the KutaSoftware website. So we want this to look like slope-intercept form, so we're going to have to do a little bit of math before we go ahead and graph. If you wanted to, you could also plug in values for x, solve for y, and then plot the points from there. With that method, it'd be helpful to use a t-table. Let's go ahead and do that method first, and in number 10, we'll do the slope-intercept form method. So for this, I'm picking a value for x and solving for y. I want to see when x is 0, what is y. So I'm going to write this like an equation. 3x minus 2y is equal to 10. If x is 0, 3 times x, or 3 times 0, is simply 0, so I'll be left with negative 2y equals 10. Divide by negative 2 to get that y is equal to negative 5. So when x is 0, y equals negative 5. Now I'm going to pick 2. What happens when x is 2? 3 times 2 minus 2y equals 10. 3 times 2 is 6, so that'll be 6 minus 2y equals 10. I'm going to subtract 6 from both sides. 10 minus 6 is a positive 4. When I divide both sides by negative 2 as my next step, I get that y is equal to a negative 2. So when x equals 2, y is negative 2. Now I have 2 points, so I can create my line. 0, negative 5, and 2, negative 2. This is going to be a dashed line since I'm using the less than sign. And now let's try our test point. Let's go ahead and use the same test point we've been using in the previous video, 0, 0. If I plug 0 in for x, that's 0. And if I plug 0 in for y, this quantity is 0. So I have 0 is less than a positive 10, which is true. So I'm going to shade in including that 0. Let's move on to number 10. In number 10, I'm going to start by rewriting this in slope-intercept form. So I'm going to start by subtracting 5x from both sides. I'll get that negative 3y is less than or equal to negative 5x minus 15. Then I'm going to divide both sides by a negative 3. I'll be left with y on the left-hand side, and since I divided by a negative, remember, I have to flip this inequality. So now y is greater than or equal to negative 5x over negative 3 is the same as positive 5x over 3, which is 5/3 x, and negative 15 over negative 3 is a positive 5. So now I have my slope, m, which is 5 over 3, and my y-intercept occurs at positive 5. So 0 in the x, positive 5 in the y, and then my rise over run is 5 over 3, but I'm going to make them both negative, since a negative over a negative is still positive, and go down 5 and 3 to the left. That'll put me at the point negative 3, 0. And since my sign is greater than or equal to, we're going to use a solid line. Now we just need to use the test point. Let's use the point 0, 0. And you can plug that test point into the original inequality or into the new inequality that we've acquired. Let's go ahead and plug it into the original since it'll be easier. If we plug in 0 for x and 0 for y, 5 times 0 is 0, 3 times 0 is 0, so we'll be left with 0 on the left-hand side, less than or equal to negative 15 on the right. Is that true? No, 0 is greater than negative 15, so we're not going to shade in the region that includes 0, 0, we're going to shade in the other region. And that's the answer to number 10. In number 11, our slope is 0, so it's going to be a horizontal line. What we need to do is locate the y equals 4 line, and it's going to be solid since it's greater than or equal to. And now we just have to decide which way we're going to shade, where if y is everything greater than or equal to that 4, that's going to include 5, 6, and so on, so we're going to shade above that y equals 4 line. And that's the answer to number 11. In number 12, let's go back to our t-table method. We're going to pick a value for x and solve for y using x minus y equaling 2. So if we pick an x value of 1, we're going to have 1 minus y equals 2. Subtract 1 from both sides to get that negative y equaled a positive 1. So if we divide or multiply by negative 1, we get that y is equal to negative 1. So when x is 1, y is negative 1. And let's see what happens when x equals 2. When x is 2, we have 2 minus y equals 2. Subtract 2 from both sides to get that negative y equals 2 minus 2, 0. Multiplying or dividing by negative 1 to each side gives us that y equals 0. So when x is 2, y is equivalent to 0. Now let's plot those 2 points. 1, negative 1, 2, 0. And those are going to be connected with a dashed line since it's greater than, not greater than or equal to. And now let's use our test point of 0, 0. Plugging 0 in for x and 0 in for y, we get that 0 is greater than 2, which is not true. Therefore, we shade the region that doesn't include that point 0, 0, so it's going to be everything to the right of our dashed line. And that wraps up the video for graphing linear inequalities. Like I say in all my videos, all your subscriptions and likes are greatly appreciated, so go ahead and do that now. Also, if you have any comments or requests for a certain worksheet, go ahead, leave the link in the comments below, and I'll get to that as soon as I can.